Hi, and welcome to this lesson on storage arrays, preparing for your CompTIA Storage Plus exam. I'm Nigel Poulton and I'll be your instructor for this lesson. Let's get the ball rolling by talking about what a storage array actually is. In its most basic form, a storage array is a computer. It's got processors, usually x86 or x64, it's got memory, and it's got network ports, and of course it's got disk drives. Or these days they could be flash drives, or maybe even a mixture of the two. I guess we could say that storage arrays are computers that are designed, tuned, and dedicated to providing shared storage. And like computers, storage arrays come in all shapes and sizes. Some are small enough to sit on your desk, whereas others need reinforced floors and can make big old mainframes look fairly puny. But what they all have in common is that they provide persistent and hopefully safe storage for data. Over and above that, they usually provide mechanisms for protecting data, things such as RAID, redundant components, replication technologies, and many other advanced features. It's quite common to hear people refer to storage arrays as shared storage arrays, as most arrays are connected to a network that allows their resources to be shared by multiple hosts that are attached to the same network. And that mention of networking brings us nicely to our first point, or our first distinction, the difference between NAS and SAN. NAS is an acronym for Network Attached Storage, whereas SAN is an acronym for Storage Area Network. And there are a couple of major differences between NAS and SAN. First up, the kind of network and network protocols used to access each. NAS arrays connect to Ethernet networks and communicate with hosts over TCP/IP based protocols such as NFS and SMB CIFS. This network can be the shared corporate LAN, or more often than not it can be an isolated ring-fenced network with dedicated hardware just for storage traffic. Either option is fine, but having that dedicated network with its own hardware usually provides better and more predictable performance as well as better security. The higher level protocols that run over TCP/IP that are used for NAS storage are NFS in the Linux and Unix world and SMB CIFS in the Windows world. Although Linux and Unix servers can have Samba clients that allow them to communicate with NAS arrays running SMB CIFS, and Windows hosts on the other hand, they can also have NFS clients allowing them to communicate with NAS arrays using the NFS protocol. Now NFS is an acronym for Network File System, whereas SMB and CIFS are two acronyms that for all intents and purposes refer to the same protocol. The correct term to use is SMB, which is an acronym for Server Message Block, whereas the less correct, but I hasten to add the more popular term, is CIFS, CIFS, which is an acronym for Common Internet File System, but SMB and CIFS are used interchangeably and refer to the same protocol. And we should point out that almost all commercial NAS arrays run both protocols concurrently, NFS and SMB CIFS. SAN-based storage arrays connect to hosts usually over a dedicated physical storage network running the Fibre Channel Protocol, FCP. This Fibre Channel SAN is totally independent of the corporate LAN and it's not based on Ethernet. Hosts and storage arrays that attach to a SAN require dedicated Fibre Channel Host Bus Adapter cards. We call these HBAs for short. They're effectively NICs designed specifically for Fibre Channel networks. These HBAs are standard PCIe expansion cards that slot into the PCIe slots on any standards-based x86 and x64 motherboard. Fibre Channel networks are high speed, low latency, especially when we compare them to traditional Ethernet networks and traditional Ethernet switching technologies. Dedicated Fibre Channel SANs like this provide the best performance from a shared network perspective, but they carry the highest cost due to the fact that they require dedicated network hardware. Now, an emerging technology that attempts to address some of the cost that's associated with running a separate dedicated SAN is Fibre Channel over Ethernet, FCoE. FCoE is exactly what the name suggests. It's Fibre Channel Protocol running over Ethernet networks. There's no IP involved in this. Fibre Channel frames are encapsulated within Ethernet frames or datagrams and delivered over physical Ethernet networks. However, In order to accomplish this while still maintaining the performance and reliability of the Fibre Channel SAN, which FCoE is after all attempting to replace, this required many modifications to the Ethernet protocol, so much so that a new version of Ethernet had to be designed. This is known as DCB, or Data Center Bridging, and it was invented based on 10 gig technology. It's also worth pointing out though that DCB is sometimes referred to as CEE, Converged Enhanced Ethernet, and among other things it divides Ethernet networks into logical lanes. Each of these lanes can have certain priorities. One of these lanes is dedicated to Fibre Channel traffic and is used to provide lossless delivery of Fibre Channel frames. So just to summarize quickly, NAS arrays talk to hosts via IP-based protocols such as NFS and CIFS, whereas SAN arrays talk to hosts over dedicated storage area networks that are nothing to do with the corporate LAN. SANs provide faster, more reliable transport and use the Fibre Channel Protocol FCP. Now for a second major difference between NAS and SAN arrays. NAS arrays work with files and directories, whereas SAN arrays work with blocks. We often refer to storage from NAS arrays as file storage and storage from SAN arrays as block storage. So we've got file arrays and block arrays, or NAS arrays and SAN arrays respectively. File is delivered over IP networks, whereas block is usually delivered over dedicated, high-speed, low-latency Fibre Channel SANs. Now for the exception, and there's always an exception, isn't there? This time it's iSCSI. iSCSI is an acronym for Internet SCSI, and it's an interesting one, and it's one that's massively gaining in popularity. iSCSI is different because it operates over the IP network, but it delivers storage at the block layer, so it breaks from the rules that we've just mentioned. And as we mentioned earlier about NAS technologies potentially operating over either the shared corporate LAN or over its own isolated dedicated LAN, the same is true for iSCSI. But more often than not with iSCSI, it'll be a wise choice to run it over its own dedicated network. Now, this could be a dedicated VLAN, but preferably it'll be a physically isolated network with dedicated hardware. And this is for the usual reasons of performance and security, as well as simplifying troubleshooting. Another connectivity option that is popular with small businesses and businesses with small branch offices is SAS, Serial Attached SCSI. SAS is more of a direct attach option, and it lacks the scalability of richer networking technologies such as Fibre Channel, and of course the daddy of all rich networking technologies, IP. SAS is common if you want to attach a handful or so of servers to a small shared storage array. SAS delivers storage at the block layer, so as block devices, and in that respect is similar to Fibre Channel and iSCSI SAN, only it is way less scalable. So, as the name suggests, SAS is a serial protocol, meaning it sends one bit of data at a time rather than multiple bits in parallel. And serial protocols are all the rage these days, as they offer several design and manufacturing benefits over their counterparts, parallel protocols. Some of these advantages of serial protocols include simpler designs that don't need to worry about things like crosstalk and signal skew. Other advantages include the fact that they can transmit data over longer distances and have simpler and cheaper cables and interfaces. SAS1, or the first generation of SAS, is capable of transferring up to 3 gigabits per second, whereas the newer SAS2 is capable of up to 6 gigabits per second, and the uber new SAS3, 12 gigabits per second. Obviously, interconnect technologies and cables like SAS that offer higher speeds and higher rates of data throughput give better performance, but a system can only perform as quickly as its slowest component. So it's no good having a huge fat SAS pipe between your server and storage if your storage is on slow spinning disk that just can't keep up with the speed of the big fat SAS cable. So bus speed and cable speed is important, but it's only one part of the performance puzzle. And a cracking feature of SAS is that it's plug compatible with SATA, meaning that you can plug SATA drives into a SAS system. Unfortunately though, you can't plug SAS drives into a SATA system. Finally on SAS, most modern disk drives come with SAS interfaces, But as we mentioned, it's also possible for external storage systems like storage arrays to connect to servers via SAS cables. Now to finish this slide, multi-protocol arrays. Some arrays, in fact quite a lot of arrays, support multiple protocols. It's really common for a block array to deliver both Fibre Channel and iSCSI storage, or for a NAS array to support both CIFS and NFS. But some arrays take it a step further, supporting block and file access out of the same array. The NetApp FAS series, as well as EMC VNX, are probably the most common examples of this type of array. They provide everything: CIFS, NFS, Fibre Channel, iSCSI, FCOE, all at the same time, all concurrently. So let's quickly summarize this slide. Storage arrays are computers dedicated to providing shared persistent storage. They can be big or small, ranging from desktop models with 1 or 2 disk drives in them up to the real big beasts that can have thousands of drives. Storage arrays connect to networks in order to share their resources, and these networks can be shared corporate Ethernet networks running IP, or they can be dedicated Ethernet and IP networks for added performance and security. In the case of Fibre Channel though, this is usually a dedicated high-speed, low-latency Fibre Channel network. Storage arrays share their capacity as either files, such as network file shares, or as block devices that we usually call LUNs or volumes. And last but not least, some storage arrays support multiple protocols concurrently. With that, let's take a look at why we have storage arrays.